Today we're diving into a really cool new idea in AI. It's about a simple but kind of profound question. What if we could get our AIs to think in whole ideas instead of just spitting out words one after another? Well, there's a new concept called Calm that does just that, and it might be the secret to making AI way, way faster. You know that feeling, right? You're waiting for a chatbot to answer, and there's that little pause. You can almost feel it thinking as the answer just kind of trickles out, word by word. Well, it turns out the reason for that is actually pretty simple. It's just baked right into how these things work. At their heart, even the biggest, baddest models are really just word predictors. Their whole job is to guess the next token, which is, a word or part of a word, over and over and over again. But what if they didn't have to? What if an AI could just leap forward, generating an entire chunk of an idea in one go? That's the whole premise behind this new Calm framework. And honestly, it could be a complete game changer for how we build these things. All right, so to really get why Calm is such a big deal, we've got to first talk about this token bottleneck. It's like a fundamental speed limit that's holding back every modern language model out there. Now look, we've tried to speed this up before. The really early models were even slower. They worked one letter at a time. Can you imagine? Then we got subword tokens, which was a big step up. But the folks behind Calm are basically saying, yeah, that's great, but we've just hit another wall. We're still building this massive wall of text one tiny brick at a time. And here's the crazy part. The actual amount of information in one of those tokens, it's tiny, like 15 bits. To give you some perspective, that's less information than just 2 letters in a text message. The paper calls it low semantic bandwidth. It's like we built this massive supercomputer brain, but we're forcing it to communicate by sending one postcard at a time. This quote from the paper just nails it, doesn't it? We have these incredibly powerful models, but we're making them do this one tiny, inefficient task that completely throttles them. It's just a huge mismatch between what these models could do and what we're asking them to do. So how do we get around this? How do we break that bottleneck? Well, this is where we get to Calm's big central idea. Okay, here's the shift. Instead of predicting the next word, Calm predicts the next idea. So it takes a chunk of tokens, say 4 of them, and it squishes their meaning down into one single dense package called a vector. The AI's new job isn't to predict words anymore, it's to predict these idea vectors. And since each one covers multiple words, it just slashes the number of steps it needs to generate text. Now the magic that makes this happen is a little engine called an autoencoder. Just think of it like the super smart librarian. It can read a whole sentence, summarize it into a single, really complex symbol, and then, and this is the important bit, it can look at that symbol and perfectly write out the original sentence again. And when I say perfectly, I mean it. This thing is ridiculously accurate. The autoencoder can rebuild the original words from that compressed idea vector with over 99.9% accuracy. I mean, it has to be that good, right? Otherwise, the whole system just wouldn't work. Okay, but there's a catch. Being super accurate is not enough. A basic autoencoder creates what the paper calls a brittle representation. Imagine a map where if you're just a tiny bit off the right road, you end up in a totally different country. A tiny mistake in the AI's prediction could turn the output into complete nonsense. And that's just way too fragile for a model to learn from. So the real challenge was making this idea map more forgiving, and the researchers used a whole bunch of clever tricks to do it. You can think of it like this. They used some techniques to kind of smooth out the roads on the map so a little swerve doesn't send you off a cliff. They used others to make sure every part of the map coordinate was actually useful. And then they basically made the AI learn with a blindfold on, forcing it to find multiple ways to get to the same place. The result is this idea space that's both super precise and also robust. So great. We've got this robust way for an AI to think in ideas. But that kind of breaks everything else. All the tools we use for training and testing AIs, they're all built for predicting words from a set list. They're not built for this new world of infinite idea possibilities. So the researchers literally had to invent a whole new set of tools. And this new toolkit is honestly fascinating. For training, instead of doing all this heavy math to calculate probabilities, they just teach the model to tell the difference between a good idea vector and a bad one. It's much simpler. For testing, they came up with a whole new way to score the model that doesn't use the old metrics. It's a totally different likelihood-free philosophy for building these models from the ground up. All right, so the big question. After all of this new science, all this innovation,
Does it actually work? Is Callum really faster, better, and smarter? Let's check out the results.
And yeah, the results are pretty darn clear. The Calm model actually performs better than a standard transformer model. But here's the wild part. It did that using 44% less compute power during training. That's huge. It's not just getting to the right answer faster, it's actually learning more efficiently.
Now, the way it gets there is pretty interesting. Calm actually starts out learning a little slower. I mean, it makes sense, right? It's a harder job to predict a whole idea vector than just one little word. But once it gets the hang of it, the learning curve just shoots up, and it keeps getting better for longer. And this is really just scratching the surface. This paper opens up a whole new can of worms for AI research. Like, how do we make even better idea compressors? What are the new rules for how these models scale? It feels like we have to rethink almost everything, which is what makes it so exciting. And that kind of leaves us with this final, really big thought. By making this jump from single words to these continuous ideas, we might be opening the door to AIs that think on a totally different level. Are we seeing the very first step towards AIs that don't just mimic language, but maybe actually understand the concepts behind it? So that's our look at Callum. If you enjoyed geeking out on this kind of cutting-edge research with us, definitely make sure you subscribe to the channel. Thanks so much for watching, and we'll see you in the next one.